Hey guys, how we doing? Today we are going to do a demo on one of our gas laws. So in this one we're going to be testing the relationship between pressure and volume. So right here I've got a bell jar. This bell jar is hooked up to a vacuum pump, and the vacuum pump, its purpose is to suck the air out of the inside of this bell jar. Okay? And so what that's going to do is that's going to decrease the pressure on the inside. Well, if we think about our relationship between pressure and volume, if you decrease pressure, you increase your volume. So to see that, we've actually got some peeps in there, and those peeps are labeled O and T, one for Oglesby and one for Treese.
This is Team Treese right here on the left, everyone.
And we are going to have them joust to see if one can knock the other one over. And so let's see what happens when we turn on this vacuum pump. All right. They're going up.
I think they both died.
I think they both died. All right, so as I release the pressure on the inside, what you'll notice is that peep actually shrivels up. And that's because as we're forcing that pressure to rush back into the inside of that vacuum chamber, it's actually smashing those peeps into these little pieces. Hey guys, another gas law video here. So again, same scenario as we had earlier. So in this case, we've got a balloon on the inside here. So what we should see is as we are sucking the air out of the bell chamber here, our balloon, we're decreasing our pressure, right? So our balloon should do what? It should expand, right? So let's see if that happens. So it did, it expanded to fill the entire bell jar here. Now again, if I would release that pressure, rushes back in, and we'll see that balloon go back to the size that it was. Hey guys, another gas law video here. So for this one, we're going to be looking at the relationship between volume and temperature. Now, if you know with your gas laws, volume and temperature have a direct relationship. So, right now, I've got some boiling water here. I'm going to put a balloon over the top of it. So what we should be seeing is if I have increased the temperature, then my balloon should then, the gases that are in here should be expanding and they're filling that balloon up. Okay? Now, and that's what we're seeing here, right? So what I'm actually going to do now is I'm going to take this, which is hot, right? And I'm going to place it into some cold water, okay? Now, can you see the cold water? Mm-hmm. So with the cold water, we're going to be lowering that temperature back down, okay? And so what we should see is that as that temperature decreases, our volume should also be decreasing, okay? And that's what we're seeing right here. Now, look at that. So, our volume decreased so much, our balloon has been sucked onto the inside of that.
Hey guys, so another gas law demo video coming at ya. So in this one we're going to look at the relationship between temperature and pressure. So I've got a Dr. Pepper can, and I'm going to heat it over my Bunsen burner. What I'm trying to do right now is I'm trying to heat the gas inside my can. I've put about 15 milliliters of water in there, and I just want to get that water really hot and boiling. So I'm going to heat it for about 30-45 seconds, just until I see the steam coming out of the top of the can. Typically the hotter it is, the better, and the better that this demo works. I can feel it boiling now. So we're gonna go ahead and I'm going to dump it over into the cold water, and we will see what happens. So as you can see, my can is no more. So what happened is I heated my temperature up really, really hot, and then I cooled it down quickly. When I cooled it down really quickly, the pressure in the can decreased so much that the air pressure outside was greater than the pressure inside the can, causing it to collapse in on itself. So if you ever need to crush cans, you've got a really cool new method now. You ready to do some science? Part what?
3, 2, 1.
Hi children. So we're doing Mentos and Diet Coke experiment today. If you're wondering why I'm wet, it's because I had a minor incident where some Mentos and Diet Coke exploded in my face, so it's going well. That was way more fun.